Hello everyone, welcome to Laxva Maths TV. We're still on differentiation and we want to see how we can find the second derivative of a function. Second derivative, that's y prime prime. For some textbook, some will use f prime prime, some other will use the 2y over the x squared, alright? They are all saying the same thing. Now, we want to find the second derivative, so we need to get the first derivative and then the second derivative. So, this formula still applies here, where we have NaX n minus 1. Where we have the variable x, we have the coefficient, that's 2 for here, 1 here, and then we have the power, then reduce the power by 1, and then times the coefficient by the power. So, let's start. The y dx, that's the first derivative, is going to be times the power and the coefficient. That's 2 times 2 will give us 4. We reduce the power by 1, so I left with 1 there, so might not be written there. Then we have minus, this power here is 1, so times it by x and reduce 1, that will be 0. So any to the power of 0 is 1. Then to differentiate the constant is 0, so this one is gone there. If you add it up, you see half base. Now, this is the first derivative, which is f prime or y prime. Depends on the textbook you are consulting. Now, the square, the 2y over the x square for this, we are going to be working on this now as a new function. Now, apply the same law to differentiate. Now, the power here is 1 times the power and the coefficient, we see half 4. Reduce it by 1, that is 1 minus 1. Give us 0, and any to the power of 0 is 1, so we're having times 1 here. Then differentiating a constant is what? 0. So the final conclusion for this is that the 2y over the x squared is equals to 4. Now this is the second derivative, also known as the 2y over the x squared of this function.